Far below the waters of the Northwest Pacific Ocean lies one of the most astonishing geological structures ever discovered. It is not visible from satellites. It cannot be seen from passing ships. Yet beneath nearly 2 kilometers of seawater rests a colossal volcanic structure so immense that it rivals the largest volcanoes in our solar system. For decades, scientists studying the seafloor believed this region was simply part of a broad volcanic plateau. But as new technology began to reveal the layers beneath the ocean floor, a startling realization emerged. What they were looking at was not a collection of scattered volcanoes, but a single colossal structure, larger than many countries and far bigger than any volcano on land. The hidden giant we are looking at today is known as Tamu Massif. It sits within a vast underwater region known as Shotski Rise, an enormous volcanic plateau located roughly 1,600 kilometers east of Japan in the Northwest Pacific Ocean. Rising several kilometers above the surrounding abyssal plains, Shotski Rise forms a massive plateau on the ocean floor, composed of thick layers of volcanic rock. For decades, scientists believed that the plateau was created by multiple volcanic centers erupting over long periods of time. However, the southern portion of this plateau, Tamu Massif, turned out to be something very different. Unlike many volcanic systems composed of multiple peaks and ridges, Tamu Massif forms a single gigantic dome. It rises about 4 kilometers above the surrounding seabed. While that may not sound extreme compared to towering mountains on land, its true size lies in its horizontal spread. The volcano stretches roughly 650 kilometers across, creating an enormous dome of hardened lava flows that radiate outward from its center. Mauna Loa in Hawaii, often considered the largest volcano on Earth when measured from base to summit, covers an area of about 5,000 square kilometers. Tamu Massif covers more than 60 times that area. This immense volcanic edifice covers roughly 310,000 square kilometers, making it the largest single volcano on Earth, covering an area comparable in size to the United Kingdom. Scientists have noted that its shape resembles giant shield volcanoes found on Mars, including the immense volcano Olympus Mons. Although Olympus Mons is still far larger, Tamu Massif proves Earth can produce truly colossal volcanoes too. Yet, despite its size, Tamu Massif remains almost completely invisible to the world above. It has not erupted for more than 140 million years. It lies buried beneath layers of seawater and sediment, silently recording a chapter of Earth's ancient volcanic past. Before we continue, don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. The recognition of Tamu Massif as a single enormous volcano came only recently. For decades, scientists studying Shotski Rise believed it was made up of several smaller volcanic structures that erupted separately. The plateau's complex geology seemed to support this idea. Everything began to change in the early 2000s when geophysicists started analyzing detailed seismic data from the region. Using powerful sound waves that penetrated deep into the seafloor, researchers were able to map the internal layers of rock beneath the ocean floor. One scientist in particular played a key role in unraveling the mystery. Geophysicist William Sager from Texas A&M University spent years studying seismic data collected across Shotski Rise. What the team discovered was remarkable. The internal structure of Tamu Massif showed enormous lava flows radiating outward from a central point, much like the pattern seen in shield volcanoes such as Hawaii's Mauna Loa. This radial pattern strongly suggested that the entire massif formed from a single gigantic volcanic system. In 2013, Sager and his colleagues published a landmark scientific paper announcing that Tamu Massif appeared to be the largest single volcano on Earth. The name Tamu is derived from Texas A&M University, where the researchers who led the investigation were based, honoring the institution that played a key role in uncovering this enormous volcano. The volcanic activity that created Tamu Massif occurred during a distant chapter of Earth's history. Geological evidence suggests that the volcano formed approximately 145 million years ago, during the late Jurassic to early Cretaceous period. At that time, the configuration of Earth's tectonic plates was very different from today. The Pacific Ocean basin was undergoing rapid geological change, with seafloor spreading and tectonic movements reshaping the ocean floor. Tamu Massif formed near a rare geological feature known as a triple junction. This is a point where three tectonic plate boundaries intersect, creating an area of intense geological activity. At such locations, the Earth's crust can stretch, fracture, and thin dramatically. These conditions allow magma from deep within the mantle to rise toward the surface. Scientists believe that an enormous mantle plume, an upwelling of hot rock from deep inside the Earth, may have fed the eruptions that built Tamu Massif. As magma erupted onto the seafloor, it spread outward in vast lava flows that traveled hundreds of kilometers across the ocean floor before cooling and solidifying. These eruptions likely occurred over a relatively short geological time frame, possibly lasting only a few million years. For a structure as massive as Tamu Massif, that is astonishingly rapid growth. The discovery of Tamu Massif is significant not only because of its size, but also because of what it reveals about Earth's geological processes. For many years, scientists believed that structures of this scale, covering hundreds of thousands of square kilometers, could only form as large igneous provinces, regions where vast quantities of lava erupt from numerous fissures and volcanic centers. Tamu Massif challenged that assumption. Evidence suggested that the massif might have formed from a single central volcano rather than many separate vents. If that interpretation is correct, it means Earth is capable of producing volcanoes far larger than previously believed. This insight has important implications for understanding volcanic processes on Earth and other planets. It also provides clues about how mantle plumes interact with tectonic plate boundaries. In many ways, Tamu Massif represents a bridge between two different types of volcanic structures: traditional shield volcanoes and enormous volcanic plateaus. Despite its enormous size, there is no evidence that this ancient underwater giant could erupt again. Geological studies indicate that its volcanic activity ended roughly 140 million years ago, during the early Cretaceous period. After that time, the magma systems that once fueled its massive eruptions gradually cooled and solidified deep within the Earth's crust. Without an active supply of rising magma, a volcano simply cannot erupt. Scientists studying the region have found no signs of present-day volcanic activity beneath the structure. There are no detected magma chambers, seismic signals of rising molten rock, or hydrothermal systems that would suggest the volcano is still alive. Instead, the entire formation appears to be completely dormant and geologically stable. Over millions of years, the once active volcanic slopes have slowly subsided as the oceanic crust beneath them cooled and sank. Layers of marine sediment have also accumulated across the surface, further burying the ancient lava flows that built the enormous structure in the first place. Today, the volcano rests quietly beneath nearly 2 kilometers of Pacific Ocean water. While it once unleashed colossal eruptions that spread lava across hundreds of kilometers of seafloor, it is now considered extinct, posing no threat to modern Earth. The discovery of Tamu Massif highlights how much of Earth's geological history remains hidden beneath the oceans. More than 70% of the planet's surface lies beneath water, and much of that vast underwater landscape remains only partially explored. Advances in marine mapping technology are continually revealing new features: underwater mountains, volcanic ridges, and mysterious geological formations. Tamu Massif serves as a reminder that some of the most extraordinary structures on Earth may lie far from view, buried beneath kilometers of ocean. As scientists continue to explore the deep ocean floor, new discoveries will likely reshape our understanding of the planet's geological processes. The Pacific Ocean alone contains thousands of underwater volcanoes, many of which have yet to be studied in detail. Among them, Tamu Massif remains one of the most remarkable, a gigantic volcanic structure that formed in Earth's distant past and remained hidden beneath the sea for millions of years.